Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear student, Assalamu alaikum. My name is Dr. Muslim Khan, Assistant Professor, Department of Chemistry, KUST. Today, the topic of our discussion is hyphenated technique. I mean, we have to discuss GCMS and hyphenated technique. The course code is CHEM453 and the course mass spectrometric and thermal method of analysis. First of all, what is GC, gas chromatography? In our last lecture, we have already discussed what is gas chromatography. Gas chromatography is basically a chromatographic technique that can be used to separate volatile organic compound. And shortly it is called GC. Gas chromatography in short is called GC. It consists of a flowing mobile phase. While in case of LCMS, it is having a mobile phase that is liquid, but that is a flowing mobile phase that is gas, either helium, argon. Gas is used as a mobile phase. And then in sample injection port, where sample to be analyzed is injected in the path of this mobile phase. Then sample along with this mobile phase is carried to the heart of the chromatographic system, which is called column, the stationary phase, where it is separated on the basis of different interaction of these components with the stationary phase, the affinity of these different components with a stationary phase. And an oven, which can, a thermostat oven, which heat up this column along with this sample, and then a detector. This is how chromatographic system, this GC, is having this gas supply, either helium or argon, which is going to the column, which is seated there in thermostat oven. Here sample is injected, and here's different component of the samples are separated on the stationary phase, and then it is going to the detector. Here where GCMS means the combination of this GC with mass spectrometer, instead of this common detector with just like a common detector, FID, electron capture detector, but this effluent coming out of the column is directly going into the mass spectrometer, and then it is recorded. This is known as a GCMS. So MS detector uses the differences in mass to charge ratio of ionized atom or molecule to separate them from each other. You have studied the MS mass spectrometry in detail, and that what is mass spectrometer? It separated the different ions on the basis of mass to charge ratio. You know what mass spectrometer have? Ion source, which is formation of ions, and then mass analyzer, separate the different ions on the basis of mass to charge ratio, and then detector, and finally we got a spectra for this compound. Molecule have a different molecule have a distinctive fragmentation pattern. You know fragmentation pattern, my student, that provide structural information to identify structural components for this specific class of compounds. The general operation of a mass spectrometer is that it creates gas phase ion, and these separate the ions in a space or time based on their mass to charge ratio. measure the quantity of ions of each mass to charge ratio. The ion separation power of an MS is described by the resolution power of the mass spectrometer. Resolution is known as the mass divided by delta M, where M is the mass of the ion and delta M is the difference in mass between two resolvable peaks in a mass spectrum. For example, an MS with a resolution of 1000 can resolve an ion with a mass to charge ratio of 100 from an ion with a mass to charge ratio of 100.1. So this interfacing GC with spectrometric method early on, it was a problem that how to interface GC or HPLC system with MS online. So that was not, it was very difficult to make it online because GC or either HPLC was working at a high pressure while an MS a vacuum is needed. So interfacing GC with spectroscopic method, this eluents coming from the column early on, this was collected as a separate fraction. After being collection, that is detected in mass spectrometry or either. So it was very difficult to connect these two techniques. So this was called the offline collection of these different fraction and then analyzed by mass spectrometry or IR. So limitation, it is the small micromolar composition of the solute. So it was very difficult when you keep it offline for some time and then you are analyzing it. Too many changes and too many things were happening with your sample. And procedure that is still used for qualitative analysis of multi-component, but nowadays this online system which directly this GC is connected to the mass spectrometer is working. So this application of a selective detector in modern days, the detector monitored the column effluent continuously. Need computer to control the instrument and store spectral data for display of spectrum and chromatogram. So interfacing gas chromatography and mass spectroscopy, mass spectrometry. GC equipment can be directly interfaced with the rapid scan mass spectrometer. The flow rate is usually small enough to feed directly into the ionization chamber of a mass spectrometer. Packed column usually use a jet separator which removes the carrier gas for the analyte. So increase momentum of a heavier analyte molecule so that 50% or more go into the skimmer. Lighter helium molecules are deflected by vacuum and pumped away. Used to identify component present in a natural and biological system, odor or flavor of food, pollutant, etc. What is GCMS? Gas chromatography mass spectrometry is the synergistic combination of two powerful analytical techniques. The gas chromatography separates the component of a mixture in a time very well. So this is the strength of a GC, that it separates the components very well. And the mass spectrometry provides information that aids in structural identification of each component. So the power of the two techniques. So one separate the things quite well, the components quite well, while the other gives the fragmentation pattern, means the structural information of each component very well. This is how a benchtop GCMS system look like. That this GC is connected to a mass spectrometer, connected to a mass spec. This is online GCMS system look like. And this is the spectra we are getting for GC. Means we are getting at the same time, we are getting a chromatogram from GC. Chromatogram means time versus the relative abundance of each component. Then for each component, we are getting this kind of spectra as well. So it means that we get the retention time of the compound very well separated. And then for each component, we are getting the spectra. So the combination of these two techniques make it a very strong technique for qualitative as well as quantitative purposes. So the problem was how to interface this GC and MS system. So this transport the effluent from the gas chromatograph to the mass spectrometer. So how efficiently this effluent which is coming from GC goes into the mass spectrometer, this was the main problem in the combination of a GC-MS system. And analyte must not condense in the interface. And analyte may not decompose before entering the mass spectrometry ion source. And the gas load entering the ion source must be within pumping capacity of the mass spectrometer. Means the mass spectrometer should not be overloaded with a mobile phase. So two types of columns are used, capillary columns and macrobore and packed columns. So capillary column, insert exit end of column into the ion source, the interface. Under normal operating conditions, the mass spectrometer can handle the entire effluent of the column very well. Must heat the capillary column to prevent condensation. For that purpose, the capillary column is placed or it is set in the oven, thermostat oven, where you can control the temperature. You already know how the GC system works in my previous lecture. So surface of the column must be inactive. It must not react. It must interact, but it must not react to the component so that the chemical reaction might not take place. Macrobore and packed column. Effluent must be reduced before entering into ion source. Splitting the effluents result in a loss of sensitivity. So enrichment devices are used. What are the enrichment devices? Jet separator are the most common enrichment devices used in GCMS. So jet separated. Basically, there are two capillary tubes aligned with a small space between them, that is 1 millimeter. Two capillary tubes aligned with a small space between them. A vacuum is created between these tubes using a rotary pump. So in between these two tubes, vacuum is created by using rotary pump. The JC effluent enter the vacuum region, this vacuum region. Those molecules which continue in the same direction enter in the second capillary tube and continue to the ion source. The carrier gas molecules are more easily diverted from the linear path by collisions. The analyte molecules are much larger and carry more momentum. The surface of the separator must be an active and reasonably even temperature. So also prone to leaks. So with a modern mass spectrometer, it is possible to measure the mass of an ion to 1 ppm, 1 parts per million, with a resolution of 100,000 or better even. GCMS scanning conditions are limited to 5 to 10 ppm mass accuracy, and resolution is only between 2000 and 10,000. These limitations are usually sufficient to allow for only a few reasonable and possible composition. Resolution can be increased by restricting the height and width of the ion beam. A compromise must be made between minimizing mass interference and signal intensity for low level of material. Gas chromatograph eliminates most compounds that cause mass interference. Principal cause of peak overlap is the internal mass standard. So what are the uses of mass GCMS? First of all, GCMS have environmental monitoring application. GCMS has become a more highly recommended tool for monitoring and tracking organic pollutant in the environment. The cost of GCMS equipment has decreased where the reliability has markedly increased. The determination of chlorophenol in water and soil, polycyclic aromatic hydrocarbon, unleaded gasoline, dioxins, etc., organochlorine, chlorine pesticides, herbicides, phenol, halogenated pesticides, sulfur in air is a very convenient to screen by this GCMS technique. GCMS techniques also used in food, beverage, flavor and fragrance analysis. Food and beverage have several aromatic compounds existing naturally in native state or formed while processing. GCMS is exclusively used for the analysis of ester, fatty acids, alcohol, aldehydes, terpene. GCMS is also used to detect and measure contaminants, spoilage of food, oil, butter, ghee that could be harmful and should be controlled and checked as a regulated by different regulatory authority or government agencies. It is used in the analysis of piperine, spearmint, oil, essential oil, fragrance reference standard, perfumes, chiral compound and essential oil, fragrances, menthols, olive oil, lemon oil, etc., and in many places. GCMS has also application in the forensic and criminal cases. GCMS can analyze the particle from suspect to correlate his involvement in the case. The analysis of fine debris using GCMS can be established by American Chemical Society for Testing Material, ASTM, standard for the fire debris analysis. It is the key tool used in sports and anti-doping laboratory to test athlete urine sample for prohibited performance and enhancing drug like anabolic steroids. It is also commonly used in forensic toxicology to find poison, steroids in biological specimens of suspect victims or the deceased. It has also a biological and pesticides applications detections. GCMS is exclusively used in bioanalysis of food, urine for the presence of narcotics, alcohol, residual solvents, drug like anesthetic, sedative hypotics, narcotics, and food items. This technique could be used for detecting fatty acid profiling in microbes, presence of free steroids, blood pollutants, etc. This GCMS has also application in the security and chemical warfare agent detection. Explosive detection system have become part of all United States airports. GCMS is an essential part of chemical analysis unit for enhancing chemical capability in homeland security and public health uh, uh, preparedness. Traditional GCMS unit with a transmission quadrupole mass spectrometer as well as with those cylindrical ion trap and a mass spectrometer have been modified for field portability and near real-time detection of chemical warfare agents such as serine, SOMONs, and VX, etc. This is also having astro chemistry application and geochemical research. Several GCMS have left Earth for the astrochemistry studies. Two were taken to Mars planet by Viking program. Scientists analyzed the atmosphere of Venus with GCMS uh, and significantly enhanced molecular ions. This make this GCS valuable for organic geochemical application as well. GCMS has also a medicinal and pharmaceutical application. Dozens of different metabolic disease called as inborn error of metabolism are now detectable in newborn by screening test using gas chromatography mass spectrometry. GCMS can determine compound in urine even in a minor concentration. These compounds are normally not present but appear in individuals suffering from metabolic disorder. This is easy, effective, efficient way to diagnose problem like in case of genetic metabolic disorder by urine test at birth. In combination with isotopic labeling of metabolite, the GCMS is used for determining metabolic activity. Most applications are based on the use of carbon-13 labeling and the measurement of 13C12C ratio with isotopic ratio mass spectrometer and MS with detector designed to measure a few select ions and return value as a ratio. It is useful to detect oils in creams, ointment, lotion, etc. GCMS is also used in pharmaceutical industry for analytical research and development, quality control, quality assurance, production, pilot plants, the department for active pharmaceutical ingredients, bulk drug and formulation. It is used for the process and method development, identification of impurities. It is integral part of research associated with the medicinal chemistry, synthesis and characterization of compound, etc. So these are the uses of GCMS. So thank you very much for this hyphenated technique. And these books can be used, G.D. Christian, Scrooge and West, this fundamental of analytical chemistry can be used for this lecture. Thank you very much.